Hello, you are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. Today's section, we continue from where we ended, during the previous week, meeting. My friends, let me remind you that I've done about 4 or so videos regarding this general embryology that we began. Now, it's a whole series that I'm going to take you through so that you can, understand, what happens to all these important things, in intrauterine life period. Yes. So we began looking at what we call gametogenesis. We've done oogenesis. We've done, spermatogenesis. My friends, we've gone beyond that, yes, to look at fertilization, the process of fertilization, all those dynamics, that you need to understand. I told you that the process of fertilization is not a one-step process, it's not an event, it's a whole thing that you need to really understand the concept behind it. Then after that, yes, in our previous week, just last week, we looked at, the process of what we call, that kind of cleavage right after, fertilization, forming that so-called zygote, so that the process of that kind of cell division, which I told you, a special type of mitotic division, which we call a cleavage, yes, giving rise to those daughter cells, we call them blastomeres. Eventually, yes, beyond A cell stage, going through something we call compaction, and then of course at about 58 to about 64 cell stage, forming something we call blastocyst by the presence of a cavity in there, which we call it blastocele, yes, so that we form this kind of blastocyst, the implantable form of the conceptus. Yes, so my friends, if you don't watch all these videos, kindly get all those video links and watch them, so that at the end of the day you become a guru as far as the concept of general embryology is concerned. So my friends, today what we want to look at is to look at what happens in week 2 of intrauterine life period. My friends, I want to tell you something, that the process of fertilization together with implantation is something we call week 1 of intrauterine life. Yes, week 1. And usually the week 1, the process of fertilization will happen in week 1. Some cleavage divisions will take place. But my friends, implantation, I told you that it will begin at day 6 of intrauterine life period, after conception, day 6. Which I told you that because human beings, we show interstitial implantation, which means that there's that kind of complete implantation of the conceptus by way of the blastocyst, burrowing through the wall, of the endometrium. In this case, we call it the decidua. I will take you through what happens, the sterilization, usually will happen to also the formation of the placenta. I will take you through that one. But for now, we want to look at what really happens to the embryoblasts, importantly. Now, so just to build on what we began, looking at what we call last week, we want to see, now we had what we call the blastocyst. And the blastocyst was because of the presence of what we call a cavity in there, which you call it, the blastocele. Now, if you remember, we said this. So just to quickly, rent you on something, just observe these things. So we had this stage. We had a stage where I told you that we'll be having what we call the outer cell mass. Outer. So if you can see that these guys represent what we call the outer cell mass. Outer cell mass. Yes. And then I also told you that there's going to be that kind of inner cell mass. So there will be a lot of cells all around over here. Inner cell mass. Now, if you remember, I told you that the outer cell mass was also called trophectoderm, which will give rise, will mature into something we call trophoblast. So this is the trophoblast. Trophoblast, yes. Now, then the next thing is that you will see these cells, which we call them the inner cell mass. In this case, we want to call it embryoblast. Embryoblast. Yes, with of course the cavity filled with that fluid, which we are calling it blastocele. And that is why this whole conceptus is known as blastocyst. Yes. Now, one important thing that I want you to be aware is that during the second week of intrauterine life, now we are looking at week 2 of intrauterine life. During the second week of intrauterine life, one thing I want you to know is that generally there's this kind of mantra which we say the week of 2. So second week is the week of 2. In other words, you'll be forming certain things in pairs. So you'll be seeing, yes, one entity and the other, okay, will be present, the week of 2. So what we see is that this trophoblasts, yes, will differentiate into 2. Now, one thing I told you last time is that implantation is completed around day 10 post-fertilization. But my friends, one thing that will happen is that, yes, even before implantation is complete, around day 8, what happens is that this trophoblast, cells of the trophoblast over here, will begin to differentiate into 2. And so I want you to know that. So it will begin to differentiate into 2, so that what will happen is that there will be additional cells over here. I'm just using this one to modify it. I'll be having another thing all around here. Yes, so that's what we are going to see. Now let me just clean these things briefly for you, and then I'll come back to them again. So what we will see is that it will differentiate into 2. Now one of them will have these cells, well delineated, having their own, plasma membrane, okay, separated from the other, these cells that you find over here. These cells, okay, they are cellular, real cells over here, unicellular cells, and for this reason, we call these cells cytotrophoblasts. Cytotrophoblasts. Yes. And this cytotrophoblast is very mitotic. Yes. So it undergoes mitosis, okay, to give rise to the one that I put over here, these guys over here, okay, all these guys, which, yes, they are not well delineated. Their plasma membranes, most of them have fused, okay. So it means that it's like you are having a giant cell having several nuclei. And I believe this is not the first time you're hearing that if a cell is endowed with several nuclei, then you want to say it forms a syncytium. So this is a syncytium. For this reason, this is also part of the trophoblast, which will arise from the cells of what we call the cytotrophoblast. Okay, giving rise to this guy, which forms the syncytium, which is non-mitotic. Yes, it doesn't undergo mitosis, and for this reason, we are calling this guy syncytial trophoblast. Syncytial trophoblast, yes. And for this reason, this syncytial trophoblast, together with the cytotrophoblast, these two, yes, they form what we call the trophoblast. The two differentiations of the trophoblast. Now remember already that I've told you that the second week of intrauterine life is the week of 2. Now the first thing is that the trophoblast, which is the future placenta, okay, which will ensure that there's that kind of continual nourishment of the conceptus, okay, right in what you call the uterine, right in the uterine cavity, yes, we receive that nourishment. Then we need this kind of trophoblast. Now one thing I told you, okay, let me repeat it. I told you that these cytotrophoblasts, they are cells, they are well separated, their plasma membranes are separate. So cytotrophoblasts, which will present with mitotic figures because they show mitosis, and then they will give rise to these guys, okay, to the periphery outside, which I call them syncytial trophoblasts, because at the end of the day they are fused, their plasma membranes are fused, okay, they are not well, separated from, one another. having several nuclei over there, and therefore we call it syncytial trophoblast. My friends, one thing I want to tell you over here is that this guy's syncytial trophoblast is very important. Now, for what reason? The first thing that you need to be aware is that right after ovulation, okay, the remnant of what we call the Graafian follicle will be reorganized into a temporary endocrine structure. Yes, and that's that structure we call corpus luteum. Corpus luteum. Now, my friends, that corpus luteum, we call it corpus luteum of menstruation. Corpus luteum of menstruation. Now, what that one is going to do is that it will be relevant in production of a lot of what we call the progesterone, and of course small amount of what we call, estrogens, and a lot of the progesterone. And one thing that we know about progesterone, previously from our senior high school, we're told that progesterone helps maintain pregnancy. Yes. For this reason, it will be making a lot of progesterone, corpus luteum. And making a lot of progesterone, now, it means that this corpus luteum menstruation, okay, its maintenance for about 2 weeks, that's 14 days, is under the candidacy of a hormone, which we call luteinizing hormone. Corpus luteum, luteinizing hormone, helping to maintain it, corpus luteum of menstruation. Now, one thing that we have to know is that if fertilization doesn't take place, and therefore there's no conception, then this corpus luteum will be converted to become corpus albicans. Okay, so from yellow body corpus luteum to a white body corpus albicans. And for this reason, this corpus albicans will be useless as far as endocrine function is concerned. It will not be able to make these kind of sex hormones I'm talking about. Yes, it means there's no conception. So we don't need the uterus to be, well prepared for implantation. But if implantation takes place, or if there's that kind of conception, then what we are saying is that this guy, which we are calling a syncytial trophoblast, yes, will have to secrete one important hormone from it. I'll be taking you through the formation of placenta. We'll go into that detail. But this guy will be making one important hormone, and that important hormone is known as HCG, human chorionic gonadotropin. My friends, this guy, the HCG, okay, usually is the beta form. We are looking at the beta form, not the alpha form. The alpha form is just like the other gonadotropins, like estrogens, progesterone, but I'm interested in the beta form, because this beta form is the one which will be secreted by cells from these guys by way of the syncytial trophoblast, and this time around it is going to stimulate this corpus luteum to continue secreting these large amount of progesterone and estrogens, so that it doesn't become, corpus albicans. Now it's going to secrete this, okay, up to about, the 8-week post, fertilization. Yes, about 2 months. It's going to continue to secrete this after, LH, has stopped, influencing this corpus luteum of menstruation. Now, for it to stimulate it, because there's implantation, there's fertilization, there's conception. That's why this syncytial trophoblast is making this HCG to stimulate or to ensure continual production or continual survival of what we call, corpus luteum, to make a lot of progesterone. For this reason, that corpus luteum beyond 14 days will be called corpus luteum of pregnancy, or corpus luteum gravidarum. Yes, that's what we'll be seeing. But my friends, beyond 2 weeks, the placenta itself, which will be formed from the trophoblast, will come and take over the production of progesterone. Yes, that's what is going to happen. So, I'm not going into that detail because we take our time and go through the formation of placenta. We look at that. Yes, one more thing that you may be seeing is that there will be some kind of lacunae. Okay, there will be some kind of spaces which will be eventually be filled with some blood in here, okay, in the syncytial trophoblast, okay, over here, which will be continuous with, of course, the maternal, sinusoidal blood vessels, okay, so that we establish that kind of fetal placental circulation. I will explain all those things for you. And then, of course, sometimes what we see is that these guys, by way of these cells, we are calling them cytotrophoblast, will be invading the vicinity of what we call the syncytial trophoblast, and they form something we call primary, villus of placenta. So you have this whole thing, which will become the primary villus of placenta. I will explain those things for you. But for now, what I want to say is that the first two things we've seen is the differentiation of the trophoblast into cellular cytotrophoblast and syncytial trophoblast. Now, what else happens? Yes, something else happens, and I'm interested more in what happens to the embryoblast. Because, my friends, what happens to the embryoblast is that I want to clean it and show you what happens to the embryoblast will be that there will be, let me say, there's an axis, okay. What is going to happen is that these cells of the embryoblast will also differentiate into two. First, by forming some group of cells below this axis, okay. So some group of cells will be formed below this axis, and these cells, my friends, they are cuboidal cells. Now, these cells, okay, because they are below the axis, they are part of the embryo, we are going to call it hypoblast. Now, let me use blue to show it. These cells, we call them hypoblasts. Cells of the hypoblast. Yes. So we have this hypoblast. Now, one thing I want to tell you is that the cells of the hypoblast, they form something we call primitive endoderm. So cells of the hypoblast also called primitive endoderm. Yes. And then it will be followed by some group of cells, my friends, this time around above. Let me use red to cell from the embryoblast, but I'm using different color to show it. Red to show it. This time around, they are not cuboidal, my friends, they are columnar cells. These columnar cells, they refer to them as, because above this axis, we are calling it epi. The word epi is above, epiblast. Cells of the epiblast. Now, for those of you who watched the first video regarding the general embryology, where I explained gametogenesis to you, I told you some proximal cells of the epiblast, okay, they will form the primordial germ cells. I told you happen in the second week of intrauterine life, and that's the justification. We are looking at the second week of intrauterine life, the week of 2, so that the embryoblast will differentiate first into what we call hypoblast, where is the primitive endoderm, and then, of course, epiblast. And my friends, the epiblast is primitive ectoderm. Now, whenever I use the word primitive, it means that is the initial one, an ancient one, which will be replaced to eventually be replaced with a modern one. Yes. So it means that these guys, they are not definitive. They are not the final endoderm and ectoderm. They will be replaced. That is why we are calling them primitive. Yes. So these are the things that I want you to know. Now, one more thing happens. Yes. The week of 2. What we see is that there will be these cells, okay, of the epiblast and then the hypoblast. Okay, they will proliferate to line this area, okay, of the cytotrophoblast. So let's see what happens. So cells of the, so these guys, cells of the epiblast, so they are in red, so I'm using red to show. They will proliferate, giving rise to some cells, okay, to line that area, okay, facing, okay, in the vicinity of what we call the, cytotrophoblast, so that they enclose a cavity over here. My friends, this cavity created over there is known as amniotic cavity. Amniotic cavity. Yes, so I want to put that one too over here. This cavity created over here is known as amniotic. Amniotic. And that is why these cells of the epiblasts, which are lining the area of the cytoplasm, okay, will be called amnioblasts. Amnioblasts. So my friends, you may also see amnioblasts. These guys, okay, I'm calling them amnioblasts. So amnioblasts came from where? From cells of the epiblast. My friends, either you call them amniogenic cells or amnioblasts. Yes, that's what we see. Now, one more thing. So the cells of what we call the hypoblast also proliferate, okay, to line that area of the cytoplasm which is opposite to them. Okay, so let me also use blue to show. Yes, my friends, these cells, let me use blue to show them. We call these cells, will form a membrane, which we call it exocoelomic membrane. Exocoelomic membrane. Something which is also given an eponym, which we call a Hughes membrane. So someone's name, Hughes. Hughes membrane. Yes. So Hughes membrane, where did they come from? From cells of the hypoblast. So that they also enclose a cavity over here. And my friends, the name of that cavity, okay, is known as exocoelomic cavity. Yeah, because the membrane is called exocoelomic membrane. We call this cavity exocoelomic. Something you may also call primary yolk sac, or some you can say primitive yolk sac. Yes, that's what we are going to see. Now, just to try and remind you of something, what is the last thing I'm going to do today? When you are at senior high school, I'm sure you learned about the embryonic germ layers. And whenever we talk about embryonic germ layers, yes, most people know about it. That we're talking about ectoderm, you're talking about mesoderm, you're talking about endoderm. But my friends, we will see these three definitive germ layers in the third week of intrauterine life. But in the second week of intrauterine life, you've seen the primitive endoderm, you've seen the primitive by way of the hypoblast, primitive ectoderm by way of the epiblast. Now, how about the third germ layer? But my friends, that one will form outside the embryo proper. For this reason, there's a third layer I want you to know in the second week. Although we've seen the two things already, there's a third thing that I want you to know. And my friends, that is what we call the extra embryonic mesoderm. Because it's found outside the embryo proper, we have what we call extra embryonic mesoderm. And my friends, that's the last one I want to show you over here. So let me just, clean these things, okay, from here and then explain that one to you. So we've seen two things. We've seen trophoblasts differentiating into two: cytotrophoblasts, syncytial trophoblasts. We've seen embryoblasts differentiating into, of course, hypoblasts and epiblasts too. There's this one I want you to know. Pay attention over here and observe it carefully. Now, what have we seen? We've seen that there will be cells from the hypoblast, columnar shaped cells. Yes, we've seen the epiblasts with the amnioblasts from the amniotic cavity, AC, amniotic cavity. And what else have we seen? We've also seen that we will be having some cuboidal shaped cells, and then Hughes membrane. Yes. And we've seen that we have some cells the cytotrophoblasts, and we also seen that there will be some other cells forming this syncytium, by way of the syncytial trophoblast. We've seen that. But then, one more thing that we'll be seeing is that I told you that there will be a mesoderm from outside the embryoblast. But it will be formed, okay, within the trophoblast. So somewhere between the embryoblast or the embryo proper, and then of course the trophoblast will be having another, let me use this black color to show. There will be another area, this whole place will be called mesoderm. But this mesoderm that we are having is from outside the embryo proper. Therefore, we call it extra embryonic mesoderm. Now, one thing that we see that there will be some small cavities formed within it. So there will be some small cavities, okay, formed within this extra embryonic mesoderm. And then eventually, these cavities will coalesce, fuse together to form a large cavity, which will be called its extra embryonic coelom or extra embryonic cavity. So that's what we are going to see. So all these areas, what you see in black, is the extra embryonic coelom. Yes. So now what have you seen? Now this was the yolk sac. Yolk sac. Now it is that portion of the yolk sac which will be used to form this extra embryonic. Now what we see? Now this organ, the one in black that I've shown with the dots, is the extra embryonic mesoderm. Extra embryonic mesoderm. And that extra embryonic mesoderm, where did it come from? Now initially there was that kind of controversy whether it was coming from cytotrophoblast, okay, because very close to cytotrophoblast, or it was coming from the yolk sac. So my friends, it's actually come from the primary yolk sac. So it is derived from. We derive from the primary yolk sac. That is extra embryonic mesoderm. Now I'll show you something over there. Now, with the help of this, there's a cavity which has been formed over here. And this cavity which is formed over here is called something called, extra embryonic cavity. Something we also call chorionic cavity. Chorionic. Chorionic cavity. So that cavity formed over there. Extra embryonic coelomic cavity cavity or chorionic cavity. That's what we see here. And my friends, with that, we'll be able to differentiate this extra embryonic mesoderm into two. One which is very close to the yolk sac. Now, one thing I want you to know is that the yolk sac is the one which is going to give rise to some viscera. Now, internal organs derived from endoderm, we call it viscera. For this reason, what we say is that anything which is very close to the yolk sac will be called viscera. And another one for viscera is splanchnic. For this reason, we will call this guy over here. This guy here will be called splanchnopluric. Now let me just put it over here. Splanchnopluric. Extra embryonic mesoderm. Splanchnopluric, extra embryonic mesoderm. And anything further away from the yolk sac to the body wall will be called somatopluric. So this layer, somatopluric. Somatopluric extra embryonic mesoderm. So now what have you seen? Even the extra embryonic mesoderm has differentiated into two. At the week of 2, as we get to the end of the week of 2, has also differentiated into two. Somatopluric, and that's to the body wall, somatic. And then splanchnopluric to the viscera. We differentiated into two. Yes. Now, one more thing that we will see is that I want to show you over here. From here, okay, from this, now what I mean is that combination of what we call the somatopluric extra embryonic mesoderm together with, of course, cytotrophoblast and then the syncytial trophoblast, or simply say trophoblast, together will give us one of the fetal membranes, something we call chorion. My friends, that is why the cavity over here is called chorionic cavity. Now what else? There's another membrane that I want you to know. And that membrane, this time around, this time I'm not talking about the somatoperic, this time it's the splanchnoperec, extra embryonic mesoderm, together with, of course, this time we are looking at the amniogenic cells. Amniogenic cells together will form amnion, because coming from the amniogenic cells, so we call it amnion. Also a fetal membrane, amnion. Okay, so I want you to know these guys. The distinctions, where are they coming from? I want you to know them. Now, if you realize, if you look at it closely, there's one point where the coelom, okay, all those small cavities didn't fuse. Yes, so there was no fusion around this point. Why? Otherwise, the embryoblast will be floating in there. It needs to be suspended in there. In the chorionic cavity, it needs to be suspended in there. For this reason, there's one area which, of course, those small cavities didn't fuse. It means that that area, the extra embryonic mesoderm, is not differentiated into splanchnoperec and somatoperic. That is why we say undifferentiated extra embryonic mesoderm. And my friends, that is the one which we'll be calling it, will form something called connecting stalk. Connecting stalk. So this area over here is the one which is undifferentiated, giving rise to what we call the connecting stalk. Why? Because this time it is what? Undifferentiated. It is the one, my friends, which will be the future umbilical cord. The future umbilical cord. Yes. So these are the important things that I want you to know in the week of 2, second week of intrauterine life. 1, week of 2, number 1, we've seen that the trophoblast will differentiate into cytotrophoblast and cystotrophoblast. That's 1. Number 2, the embryoblast will give rise to hypoblast and epiblast. That's number 2. Even the extra embryonic mesoderm is differentiated into splanchnoperec and somatoperic extra embryonic mesoderm. Except this area, which are called the connecting stalk, which will give rise to the future umbilical cord. Yes, but my friends, we still have our yolk sac over here. Portion of it was used to form this extra embryonic mesoderm. So the remaining will be called secondary yolk sac, or the definitive yolk sac. So my friends, this guy right now is called definitive, or the secondary. Yes, so that's what we are going to have. So even in the week of 2, you saw that there was primary yolk sac. That's one of it. Eventually becoming secondary yolk sac. 2 things we've seen. So my friends, I hope you find this meeting helpful. Next week we are going to the 3rd week of intrauterine life. I'm very grateful for your time this evening. Have a good night, all of you, and may the good Lord richly bless you. Amen.